Okay, we are doing the 4.2 practice problems. That's 4.2. First question. At 27 degrees Celsius, 5 identical rigid 2-liter vessels are filled with nitrogen and sealed. 4 of the 5 vessels also contain these 4 items as we see here, as shown in the diagram above. The volume taken up by the solids is negligible, so the volume is not important. And the initial pressure of nitrogen in each vessel is 700. This is the pressure. This is the initial pressure. All 4 vessels are heated to 127 degrees, but it started at 27, so it increased 100 degrees Celsius. Right? And it's allowed to reach a constant pressure, so the pressure probably also increases. So temperature increases, pressure increases. At 127 degrees Celsius, the pressure in vessel 1 is found to be higher than in vessel 2, so this one is higher. Which of the following best reactions accounts for that observation? So now, if the pressure went up, then that means that there's more particles, right? So let me write that down. If pressure increases, that means there are more particles. So we got to find an answer that gives us more particles.
Good morning, Weekly family. At this time, all staff assigned to convocation, please report to the gym. All staff assigned to convocation, please report to Stone Gym at this time.
So we have to find which of these answer choices breaks down, right? Because first of all, we have to make sure we start out with this, right? NaHCO3. In all the cases we do. And so in this one, what happens is this doesn't break down into gas. This one has to break down into gas. That's how we can get more particles. So here it's 2 solids. This one doesn't make sense. This one doesn't make sense. So out of these 2, this one makes this and this, but this one here makes a whole lot of gas. And so I would go with C, because C makes a whole lot of gas. And the more gas leads to more particles, leads to higher pressure, which makes sense. Question number 2. Which of the following net ionic equations for the reaction between aqueous sodium and fluoride and hydrochloric acid? So fluoride grabs, so a strong acid HCl would drop the Cl and the fluoride would grab it. So which of these examples would it be? Because there needs to be aqueous sodium, fluoride, and hydrochloric acid. But the hydrochloric acid wouldn't do anything. So what would happen, right, is we have sodium fluoride, so NaF, plus HCl. So what happened is this guy would grab him. This is the most electronegative, and then we have HF. I can't tell you what this and this would do. Would they join together? Perhaps. They don't really change, right? So net ionic means what changes, right? Net ionic means what changes in the equation, right? So I would pick D, because that's actually what changes. Oh, I didn't know I could write like that. Oh, cool. Sorry about that. Next question. Equal volumes of 0.2 mole solutions of lead nitrate and potassium bromide are combined to form lead 2 bromide as yellow precipitate Which of the following is the correct net ionic equation for this reaction? So what's happening is this is a precipitation reaction. They tell us here there's a yellow precipitate. Right? And then there's something here, equal volumes of this and this. They're combined to form lead bromide. Which of the following is a net ionic equation for the reaction? So whatever it would happen, it would have to end up with just lead bromide, because that's the only net ionic. Like, what is it creating, right? What is changing? Remember, net ionic means what changes. So it creating the precipitate is what changes. So you want an answer that has lead bromide in it, and there's only one answer with just lead bromide in it, and it's this one. Lead is Pb, and then bromide is Br. And I guess this has a charge of positive 2, and this has a charge of negative 1, so it'd be 2 of them. So this, oh yeah, it does have a charge of positive 2. And this has a negative, but it's 2 negatives, so they cancel out, and so that's that. So yeah, so when they ask you for net ionic equation, it's about just what changes. Okay, the next questions are on the next page. Okay, let's zoom in. Okay, net ionic, again, I believe, right? Yes, net ionic equation. So the reaction between aqueous strontium chloride and aqueous potassium sulfate forms a precipitate of strontium fluoride. Which of the following represents the net ionic equation for the reaction? So since they create strontium, so we're looking for this, as that's the only thing that changes. Which of the following, so precipitate, it doesn't form anything else. So again, you can't, so here's the rule for this net ionic stuff. Cancel all spectators. So anything that's just like around, that's not really changing, you cancel it. So here, we already know this is what it creates. This is a pretty easy question. Since that's insoluble, it can't be broken down. Okay, next question. This question says, when the equation above is balanced and all coefficients are reduced to their lowest whole number terms, the coefficient for O2 is, oh, so you're just like balancing this equation. So first, let's balance C. So here we have 10C, right? But we have 1C here. So this would need to be 10, right? And then there's O2 here, O2 here, and O2 here. So there's O here and here. So then, but there's hydrogen here. There's 12 hydrogen here. So here, I would put a little, there's 10 carbon here. Now I would do it as a list, but I don't have the space, and I have 10 carbon here, right? And then I have 12 hydrogen here, right? So I would need 6 H2O to make 12 hydrogen here, right? There's no other hydrogen on this side. And so, okay. And then sulfur, I would have 1 here, so 1 sulfur. And so I would have 1, let's put a 1 here, 1 sulfur here. And so now let's count all the oxygen. There's 4 oxygen here and 2 oxygen here, so that's 6 oxygen. And then here there is 20 oxygen, 22, 28. So everything else is equal. There's just 28 oxygen here. So all I have to do now is try to find a way. O2 must, so 28 minus the 4 here and the 2 here. Well, the 4 here, so let's do 28 minus 4, right? It's 24. And then so if we put a 12 here, that would give us now 24 plus 4, which would give us now 28, and everything would be balanced. So the answer is C. So it's just balancing, just playing around with what you can, what's easier to balance, right? Okay, and then the next question. When the equation above is balanced, all coefficients are reduced to the lowest whole numbers. What is the coefficient for H3PO4? And so here we have, let's do this again. And always oops, what did I do? You're always drawing the line right around where the arrow is. You don't want to confuse yourself. Let's start with this. And then that's 1. So that gives us 3Ca. And then here, PO4 is kind of its own like group. So 2PO4, and then we have also we have H3PO4. We have 1. Okay, and then here you would need at least 3 here, so you have 3 Ca. You would have 6 H. Right, and then let's say you would have 2 PO4s. Okay, and so what you would have to do is to kind of get this 3 H's to match this, you would have to put a 2 here. Oops. So now you have 2. And then now this would change. Now you would have 2. Excuse my handwriting. 2 of these, right? You have 2 H3PO4s, which is kind of what we're looking for, right? We have 2 PO4 things, and 3, but here we would have CA, there's 3 of these, there's 2 of these, there's 2 of these. All coefficients are reduced. And then we have 3Ca H2PO4. Would that balance it? 6. That would give us 6 hydrogen. But the PO4s here would double. That balances? Reduced to lowest whole number terms. Yeah, we have 3. No, I think I made a mistake. CA, we have 3 of these. PO4, we have 2 of them. So we have 3 of these, we have 2 PO4s, and we have 2 H3PO4s, right? But then on this side, we have 3 CAs. We have 6 hydrogens. And we have, here's the issue. We have PO4, we have 2 PO4s times 3. So now we have 6 PO4. And here we have 2 PO4 and 2 PO4. Now we have to double this one, making it 4. Now we'll have 1, 2, 3, 4, 5, 6. Now we'll have 6 PO4 on this side. So the answer here is D. Okay, same thing here. What is the equation? So let's start with there's 3 carbons, there's 8 hydrogens, and there's 2 oxygens. There are, off the bat, I would put a 4 here because there's only hydrogen here. So 4 times 2 is 8 hydrogen now, right? So that checks out. We'll talk about the oxygen last. Carbon, there's 3 carbons here, so I would put a 3 here. So now you have 3 carbon, that matches. Now that I know the oxygens aren't going to match, so we're going to have to find a way to make the oxygen match. And I think this will be where I go to mess around with the oxygen, which is what they're asking for anyways. Isn't that crazy? And then, so 3CO here would be 6. So for oxygen, I would have 6 plus, because 3 times 2 is 6, and then 4. 6 plus 4 is 10. And so I would just put a 5 here. And that would turn 5 times 2 is 10. And so now I have 10 here. So they're asking for the coefficient here. It's a 5. What, last one. So, above which, so same thing here. We are doing the same thing. Li, let's say Li. See, this is how I would normally do it. 1, and then H. We have 1 here, and we have 2 here. So let's say we have 3. Also, like, make in your mind, be ready to change these at any time. And like this example was easier because there was oxygen by itself. So when we need to manipulate oxygen on this side, I could just manipulate oxygen and it won't mess with anything else. This one is a little bit complicated because there's multiple, they're all molecules. So here, carbon, it's 1. Oxygen is 3. No, oxygen is 7. Because of this 3 and then this 4. Hydrogen, did we count these 2? We did. 1 plus 2 is 3. And sulfur is 1. Here I have Li is 2. S is 1. So that checks out. Oxygen, I'll count that last. Hydrogen, I have 2. Oxygen we'll count later. Carbon, I have 1. I also have carbon 1 here. And then oxygen, I have 4, plus 2 plus is oxygen, I have 7. Make that oxygen. So, okay, what needs to be manipulated? So there's oxygen 7, oxygen 7. Oxygen seems to be happy. Lithium here is 1, so whatever here needs to be 2, and that now affects everything here. So now, automatically, lithium is now 2. Hydrogen is now here on this side. This 2 plus this 2, so now hydrogen is 4. And mind you, this might need to be changed again. Carbon is now 2. Oxygen is now 6 plus 4 is 10. And then sulfur stays 1. Lithium on, so now what do we need to do to match all of that, right? So what changed? Lithium is now cool. Hydrogen needs to be doubled. So the only place hydrogen could be here is I would put a 2 here, so that automatically changes this to a 4. And that doubles the oxygen. So that technically adds 1 oxygen to the side. That's an 8. This carbon is a 2, so that I would put a 2 here because there's only carbon here. Now this 2 would turn this into a 2. And then this oxygen would add 2 more oxygen. So the oxygen now is a 10 count of oxygen. What else is not the same? So now we have 10 oxygen here, 10 oxygen here, 1 silicone here, 1 silicone here, 2 lithium here, 2 lithium here, 4 hydrogen here, 4 hydrogen here, 2 carbon here, 2 carbon here. This is done. What is the coefficient in front of H2O? 2, and that's all, folks.